Hello everyone and welcome to my channel Chemistry by Miss Nidhi Banga. Today we will be talking about electrolysis. We will discuss what electrolysis is and how it happens and all the 4 electrolysis in your syllabus. Electrolysis of water, molten NaCl, electrolysis of brine and electrolytic refining of copper. We will compare and contrast them in terms of their diagrams, in terms of the electrodes used, the electrolytes used, the products formed at anode and cathode, and obviously the reactions. So all this we will do so that you can remember them nicely. Okay, so let's get started. Okay, so let's first learn what is electrolysis. Electrolysis, the word, if we break this word, we get electro and lysis. Lysis means to break. Electro comes from the word electricity. So basically, electrolysis means that we are breaking something using electricity. And what is being broken here? The electrolyte is being broken. So in all the electrolysis, we use an electrolyte, which is an ionic compound made up of 2 elements at least. And those elements are being sent to their respective electrodes. They get deposited on their electrodes using electricity. Okay, so this is what electrolysis means. And these reactions which are happening, the dissociation of electrolyte does not happen on its own. It's a non-spontaneous reaction. Non-spontaneous reaction means just that. It is not spontaneous. It doesn't happen on its own. It needs some input of energy. So all the electrolysis are endothermic reactions. Endothermic means input of energy is required. What form of energy? In this case, electricity. Okay, so they all reactions, these 4 reactions that we will do, they're all endothermic. They would not happen unless electricity is provided, and they would stop happening as soon as the electricity is stopped. Okay, so now let's talk about all of them one by one. Let's begin with electrolysis of water, the simplest one. This is from chapter 1, and this is one of the dissociation reactions, right? We have combination reaction, decomposition reaction. Electrolysis of water is a kind of decomposition reaction, okay? And just like any other decomposition reaction, it's an endothermic reaction, okay? So let's learn the setup of electrolysis of water. So in electrolysis of water, or basically in any electrolysis, there are some things which are quite common. Like we would start with a vessel. We would have 2 electrodes. They will be connected by the battery. Okay. Now you need to know that battery is represented by these lines, one big, one small. The big line means the positive terminal. The small line means the negative terminal. So the electrode connected to the positive terminal would be positive. The electrode connected to the negative terminal of the battery would be negative, right? This would be common in all the electrolysis reactions or setup. And then you would have an electrolyte. There's going to be an electrolyte in all the in all the electrolysis, but the kind of electrolyte would obviously vary. In electrolysis of water, the electrolyte that we use is acidulated water. Now this is also very commonly asked question, what is the electrolyte and why acidulated water is used? Now, water in its purest form, that means just water, is not a good conductor of electricity. For anything to be good conductor of electricity, it has to allow electricity to pass through it. That means it has to have either electrons or ions. Now water is a bad conductor of electricity. It's a covalent compound. Okay, it doesn't break into ions unless you add acid. Acid would would break water into H3O plus and OH minus ions. So it breaks water into a positive and a negative ion. Now, which one is cathode, which one is anode is very simple to remember. If you remember this much, then rest should be easy. You also have to know that out of the 2 ions, one is cation, that means a positively charged ion, and one would be anion, that means a negatively charged ion. In this case, we are writing it as H plus and OH minus. Now, H plus is a cation So it will go to the negative electrode because opposite attract. Okay, so H plus will go to the negative electrode. Since it's a cation, the electrode that it goes to would be called as a cathode. And OH minus ion would go to the positive electrode. It's an anion, so it will go to anode. So remember this always. Cations go to cathode, anions go to anode. Okay, this is how these electrodes got their names. Okay, so now we have done the electrolyte, we have done the anode and cathode. Now it's time to get the products. So obviously, since H plus is going to cathode, the product at cathode would be hydrogen gas. And since OH minus is going to anode, the product at anode would be oxygen gas. How it happens, what transfer of electrons took place, that you don't need to know. But definitely what you need to know is the overall reaction. The overall reaction is water breaking into hydrogen gas and oxygen gas. Now just balance it. There are 2 oxygens, so put a 2 in front of water, and now there are 4 hydrogens, so put a 2 here. So this is the balanced reaction that you should know and you should mention. Now it's very clear that the amount of hydrogen produced is double the amount of oxygen produced. You can see that for every 2 molecules of water, 2 molecules of hydrogens are produced, but only 1 molecule of oxygen is produced. So the question is asked, the ratio of products formed at cathode and anode. So when the ratio is asked, ratio of hydrogen and oxygen is asked in terms of moles, or molecules, right? So what would you write? 2 molecules of hydrogen and 1 molecule of oxygen. As simple as that, 2:1. But if the ratio is asked in grams, then what would you write? See, 2 molecules of hydrogens are produced. Now, atomic mass of hydrogen is 1. H2 became 2. And now because we have 2 molecules of that, 2 times 2 would be 4. Okay. Oxygen, only 1 molecule is formed. Atomic mass of oxygen is 16. So O2 would be 32. 1/8 is the ratio of hydrogen and oxygen produced in terms of grams. Okay, this has been a board question. Now, that is all about electrolysis of water. We will now do electrolysis of brine. Okay, now let's talk about electrolysis of brine. Brine is aqueous concentrated NaCl. This electrolysis is from chapter acid, bases and salt. This process is called as chlor-alkali process. It's an industrial process to produce chlorine, alkali, that is NaOH, and hydrogen gas. Let's get started with its diagram. So it's also a very basic, simple setup. A vessel, 2 electrodes, and connected to a battery. The positive terminal is connected to this electrode, so this becomes a positive electrode. The negative terminal is connected to this electrode, so it becomes negative terminal, negative electrode. The electrolyte here is, of course, your brine, that is concentrated aqueous NaCl. Okay. Now, since it's concentrated aqueous NaCl, that means there's water there as well. So if water is there, there's going to be ions from water, and then there's going to be ions from NaCl. So there are going to be 2 positive ions, H plus and Na plus, and 2 negative ions, Cl minus and OH minus. Okay, now these ions will have a competition. the two cations will compete to go to cathode, and the two anions will have a competition to go to anode, and only one of them will win. Now, this is beyond the scope of your syllabus as to what is the reason for a particular ion to win. But thankfully, it's very easy to remember the products. So let's discuss. The product at anode, anions which are going to the anode, chloride and hydroxide, chloride would go to the anode because the product is chlorine, so it's easy to remember. So chloride will go to the positively charged electrode, will lose its electrons to the positively charged electrode, and will form chlorine gas. Since it's losing electrode, you would write electrons on the product side. Electrons are being given out. Since it's two atoms in chlorine molecule, for balancing you would put a 2 here. Now since two chloride ions are losing electrons, they are obviously losing 2 electrons. So this is your reaction at anode. At cathode, you have again H plus and Na plus, and here also the competition is there and H plus would win. Okay, H plus is going to the cathode and H plus would grab the electron from the negative electrode, the cathode, and will form hydrogen gas. Since it's H2 in hydrogen gas, it would be 2H plus, and obviously they would gain 1 electron for each H plus. So this is your reaction at cathode. Now what is left? Na plus and OH ions are left, and they will combine to form alkali. We know that bases dissolved in water is called as alkali. So NaOH is your alkali. Chlorine is one of the product, alkali is one of the product. What is left? H plus, and that would go to cathode. So even that is a product. So this is about your electrolysis of brine. Next up we will do electrolysis of molten NaCl, which is much simpler than this. Okay, now let's talk about electrolysis of molten NaCl. Now as the name suggests, it's molten NaCl. It's not aqueous NaCl. There is no water here. Okay, NaCl, you know, salt, common salt, is a solid. So it's being melted, right? So it's being heated to its melting point, and then the molten NaCl, that means the liquid NaCl without any water, is being used as an electrolyte here. Okay, now this method is also an extraction method for sodium. Sodium, as we know, is a very, very reactive metals, and like any other reactive metal, it does not exist as pure metal. It exists as compounds. So highly reactive metals are extracted from their compounds using electrolytic extraction. So that is what we are going to see here. So let's start with the setup. Setup is very simple. Like we have been having a vessel, 2 electrodes connected with battery, positive end connected to this electrode, so this becomes positive electrode, negative end connected to this electrode, so it becomes the negative electrode. The electrolyte that we are using is molten NaCl. Now here it's only NaCl, only sodium and chloride ions are there. We have learned that ionic compounds are good conductors of electricity, but only in their molten form or in the aqueous form, because it's only then when the ions are actually free to move, right? So this molten NaCl, the ions are free to move. Now, as you can guess, sodium ion, that is the Na plus ion, which is the cation, will go to cathode, which is the negative electrode. So this becomes your cathode. Chloride ion is an anion, so it will go to the anode. So this positive electrode becomes your anode. Okay, reactions are also very simple. At anode, anion goes. Okay, anion will lose its electron to the positive electrode and will form chlorine gas. And chloride has lost an electron. Each chloride has lost one electron. Since chlorine molecule has two atoms, there would be two chloride ions which would have to lose two electrons to form the chlorine gas. At cathode, cation goes, and since the cathode is a negative terminal, it grabs an electron from the negative terminal and forms sodium. The sodium formed here would be liquid sodium. So this sodium ion, so the sodium liquid is formed at cathode and chlorine gas is formed at anode. So these are the two products. No confusion at all, no competition at all. Okay, this is how we extract sodium from molten NaCl. Okay, next up is electrolytic refining of copper. Okay, now let's talk about electrolytic refining of copper. Electrolytic refining of copper follows the same basic principle, same basic setup. It has two electrodes connected with a battery. This is the negative terminal, so this is the negative electrode. This is the positive terminal of the battery, so this is the positive electrode. Since this is the negative electrode, cations will go here, so this will be termed as cathode. Since this is the positive electrode, anions would be attracted to this electrode, so this would be called as anode. Apart from that, there will be electrolyte. Now let's talk about the nature of these electrodes and the electrolyte. The main difference between other electrolysis that we had done before and this one is that the electrodes that we use here are not inert electrodes. These are the electrodes which would actually take part in the reaction. Since this is electrolytic refining, we have to refine copper so that impure copper that we obtained by reduction of copper oxide, which we obtained from copper sulfide, that copper that we obtained is not 100% pure. It's around 90 to 95% pure, but we need purer form of copper. So what we'll do is we will take that impure block of copper, a thick impure block of copper, and we will make it anode, right? And then we will take a very thin strip of copper, pure copper, and we will call it cathode. This is pure copper strip, thin strip. This is impure copper block. The electrolyte is copper sulfate, acidified copper sulfate. It has a little bit of acid in it. Why? This acid would help in solubility of copper sulfate and also with the conductivity of copper sulfate. Now we have copper here and sulfate. So what will happen when the electricity is passed is that this copper 2+ ions will go and get reduced here. They will accept electrons from the negative terminal, from the negative electrode, and will become copper solid and will get deposited here. Now as that happens, there would be a dearth of copper ions in the solution. To make up for that, copper would leach out from the anode and ultimately it will also get deposited onto the cathode. Okay, so since copper ions are coming from or are being leached out from the anode over time will get thinner and thinner. This gets thinner and thinner over time. And since copper is being deposited onto the cathode, the pure strip that we took will get thicker and thicker with time. Okay, and where will the impurities go? These impurities will pile up under the anode. Okay, these impurities are basically usually gold Au, or platinum or silver. These are less reactive metals, so they will not form ions. Okay, copper, comparatively more reactive, will form ion and will get deposited onto the cathode. Okay, now let's talk about the reactions. At anode, the solid copper from the impure block will leach out as copper ions by the loss of 2 electrons, and at cathode those copper ions will accept electrons. Since this is a negative electrode, these copper ions will accept electrons from that negative electrode and will form copper solid. So these are the reactions taking place at anode and cathode. Very easy to remember which one is made anode and which one is made cathode. If you remember that anode mud is produced and anode mud is under the anode, so anode must be impure. That is why the impurities are getting piled up under it. Okay, so the impure copper block is made anode, then obviously the cathode has to be pure copper. Okay. So here are the 4 electrolysis that we discussed: electrolysis of water, molten NaCl, electrolysis of brine, and electrolytic refining of copper. I hope now you have a clearer picture of what happens in these electrolyses, the products, their reactions, their setups, their diagrams, and questions based on them would now be a little more easier to remember and answer. So I hope this helped. If you need any other topic, if you need help with any other topic, please let me know in the comments. And if you like the video, please like, share, and subscribe.